Hi folks, today I would like to introduce you my new book, Design Pattern Language, The Timeless Approach for Software Design by me, Hassen Choura. In this long format presentation, I would like to introduce you to the language. But first of all, what is a design pattern language? Design pattern language, it's a language that will ensure communication between the different intervenants in an IT project. We will involve even the end user in this communication. This will be through the use of the design pattern language. We will see the new classification, the new groupment or family of design pattern that we will combine them to create the appropriate solution. Okay, what you will find in this book? In this book, you will find a detailed description of 30 design patterns. Also, I add a section that will allow you to distinguish the difference between each design pattern. Also, this book is useful if you will rely on frameworks or in ERP or CRMs that rely on design pattern, since have a clear definition of each design, it's a prerequisite that you need it. Okay, this book will offer you a practical guidance to use a design pattern. I will be happy by the end of the presentation if I can convince you to use the design pattern language. Without further ado, let's jump to present the plan of this presentation. For this presentation, I opt for the following plan. First, I will start by defining the pattern language. After that, I will jump to present the problematics that we face in our daily task related to design pattern and pattern language. For this presentation, I opt to present two design patterns. The first one is the strategy design pattern, and the second one is the delegate design pattern. After that, I will present the design pattern language layer. In that part, I will present the families and also the group of pattern. I will finish this presentation by presenting the concept of anti-pattern and the complexity in design pattern. Since this is an offline presentation, I opt to add a common question that I keep getting when I finish this presentation. I consider that question as a pattern question. I will give an answer to convince you to use the design pattern language. By the way, if you lose concern when you are following me in this presentation, I hope that you consider to check the pattern question. Also, I hope that when you see my answer, that you will resume watching this presentation. At this point, let's start the presentation. The first use of the term pattern language was made by the architect Christopher Alexander in his book, A Pattern Language, Towns, Buildings, Construction. In his book, the author presents more than 250 patterns. Those patterns will help to involve the user in designing his own place, since the author believes that when an architect designs a place, that place is a dead place, since he will not consider the habits of the user, in this case, the habitat. For this reason, the architect highly recommends that we will involve the user in the design phase. I cannot judge this approach since I am not an expert in this field, but this is one of the main references used in civil engineer and also computer science community. Speaking about the computer science community, I need to present one of the main reference for design patterns, which is Design Patterns, Element of Reusable Object-Oriented Software by the famous Ganga 4. In this book, the author presents more than 20 design patterns. They give a description, the use case, and also examples. At this point, I need to mention an important point that even the Ganga 4 mentioned clearly in their book that they did not present any pattern language. They just described design pattern. At this point, the question will be, what is a pattern language? In our daily project, we are facing quite complex business logic requirement that we need to fulfill, or some problem that we need to solve. If the problem is quite simple, in general, we will opt to use design pattern. Just one design pattern will be quite enough to solve the problem. But in the reality, we will end up always with those complex business logic requirements that will require a combination of design pattern to fulfill or to fix a specific business logic requirement. This set of design patterns that we will combine, we call this a pattern language. This specific combination will allow us to solve the problem. In general, when we opt to use a pattern language, we will opt for a specific relationship. For example, we may say that the pattern A will use the pattern B, or even we may opt to other relationship like a pattern A will be crossover with the pattern B to have a pattern C. All those relationships need to be defined in the pattern language that we will be able to use them in the most appropriate way. Also, we may opt for a specific classification. This specific classification will allow us to regroup the similar design pattern in a subgroup. This will allow us to pick the most appropriate pattern from that group. This will allow us to simplify the use of those design patterns to achieve a specific, let's say, task. By the way, if you look for the definition and the characteristic, I highly recommend that you opt to check this in the book, Design Pattern Language, the Timeless Approach for Software Design. At this point, the question will be, what are the problematic that we face when we use the design pattern or the pattern language? What are the problematic that we face in our daily tasks? First, there are a non-clear definition of design pattern. We will end up in general by having quite confusing between several designs, since even the structure of those design patterns are quite similar. If we will opt to, let's say, design a class diagram, we will end up with a quite similar class diagram. I will give the example of the strategy and the state design pattern. In some cases, developers may get confused, and instead of using strategy, they will opt to use state, and in cases where they need to use state, they will opt for strategy. As you may expect, as a result of this, we will end up with a code that did not reflect the real business logic requirement that we are dealing with. In those cases, even the code will be quite complex to use and to understand, since we will confuse several business logic requirement concepts that we are dealing with. What I expect personally, if I use the state, I expect that I will have state and transitions and similar concepts. What I expect when I use a strategy, I expect to use strategies, ways, functionalities to achieve a particular goal. If you will confuse those two concepts, we will end up with a mixture that did not reflect the real business logic that we are dealing with. As a result, the first problem will be that we will have a hard time to communicate the base idea. Also, the code will be inappropriate implementation, since it did not reflect the real business logic that we are dealing with. As you may expect, the name of variables and the name of methods probably will not be the appropriate. Also, this code will not be easy to extend in the future. But the main problem that we will deal with is to maintain that implementation. In that case, the maintaining phase will be challenging, since, as you may expect, it will be time-consuming, resource-consuming, and we may end up with a huge problem that we cannot even maintain, and we need to delete it. In this case, we will start from the scratch. As a solution, we propose to use the design pattern language. And the question here, what is a design pattern language? In the design pattern language, we opt to refine and redefine some design pattern. This will allow us to have a design pattern that are more precise and unique. As a result, we will be able to distinguish between those designs in more ease. At this point, I would like to give you the example of strategy and state design pattern. If I will ask the following question, what is the difference between strategy and state design pattern? This question is quite challenging since there are no clear difference between those two designs. In the design pattern language, we will opt to refine the strategy design pattern on a manner that will allow us to distinguish and to pick the most appropriate design based on the business logic requirement. Also, in this language, we will have a new classification that rely on the business logic requirement. This will allow us to pick the most appropriate design based on the requirement that we have, compared to the most used classification, which is GOF classification, that rely heavily on the structural feature, since, as you may expect, it is creational, structural, behavioral, which is relying more on the structure of the design pattern. Just to remember you, and for the clarification, the main reason of the design pattern language is to ensure communication. This communication will be between the architect and the designer from one side, and the developer, the programmer, the coder, the UX design guys, and the other side. In this case, for example, the designer will create a pattern sentence, and he will communicate that pattern sentence with the programmer. The programmer needs to interpret that pattern sentence in the most appropriate way to offer the appropriate implementation. At this part, probably the question is why we consider this as a design pattern language. We consider that the design pattern language is a language by itself, since the main author, Christopher Alexander, who have made the concept of pattern language, believe that a pattern language it's a language that will be used between the different stakeholders or intervenant in the same project. This will be a lingua franca, a lingua that will be used between all the intervenant to communicate. In another term, all the intervenant are able to create a pattern sentence and also to interpret that pattern sentence to update it if they require to update that pattern sentence. For this reason, we consider this as a language. As presented in the plan of this presentation, I will introduce two design patterns. The first one is the strategy design pattern, and the second one is the delegate design pattern. But just before this, let's have a recap. What we have seen from the beginning of the presentation is we have seen the pattern language definition. Also, we have seen the problematic that we face when we use design pattern and pattern language. And we have seen the proposed solution since we present the definition of the design pattern language. In this part, I will start by presenting the definition of the strategy design pattern. Okay, then what is the strategy design pattern? If we have n way or strategies or paths or manners to achieve the same goal, we need to opt to use the strategy design pattern. It is a quite simple and brief definition, as you may expect. For more definition, please you need to opt for the book Design Pattern Language. But in this definition, we add one constraint, and this constraint is that there are no in-between strategies. In another term, if we opt to use the strategy A, we should not jump to the strategy B. And if we use the strategy B, there are no in-between strategies. We need to opt to keep working with the strategy B. This is the difference between the design pattern language definition and the existing definitions, since other definitions may tolerate the in-between strategies. I would like to compare this to the state design pattern. In the state design pattern, we will end up in general with state A and state B, and from the state A, we will jump to the state B, and from the state B, we will use transitions to the state A. As you may remark, this will allow us to distinguish between the two designs. In this strategy, there are no in-between. You will opt to use strategy A or strategy B, but no in-between strategies. With this manner, we will be able to distinguish between those two designs. One of the most important slides in this presentation is the slides in which I will describe the forces of each design pattern. As you may remark, in the design pattern language, we opt for a simple taxonomy in which we would use advantage and disadvantage. In this part, I would like to describe the advantage and the disadvantage of the strategy design pattern. And let's start by the advantage of the strategy design pattern. The strategy design pattern will allow us to delay the decision. In those cases where delaying the decision is the appropriate decision, since in those cases, we will determine the appropriate strategy on the runtime. In another term, we will not be able to determine the appropriate strategy in a pre-compilation phase. In those cases, we will opt or we will determine the appropriate strategy on the runtime. Moreover, we can use the strategy design pattern where we have a non-clear scope. Imagine that the client asks for the strategy A and the strategy B, and also the management agree on that. But in the future, the client may opt to add the strategy C and D. In this case, we need to opt to use the strategy design pattern. Also, the strategy design pattern will allow us to support several strategies. In addition, with this design, we will be able to add new strategies in the future. Also, it will allow us to have a plan to extend the solution. This is quite different compared to non-clear scope. In this case, imagine that the client say that he needs the strategy A and B, the management agree on, but for some reason, as a dev team, we discover that in the future, we need strategy C and D. In this case, we need to offer support for this in the future. And that's why we need to opt to use the strategy design pattern. Also, with this design pattern, we will be able in the future to apply modification since there are no in-between strategies. In case of we require to update the strategy A, we will be able to update it or to maintain it without impacting the strategy B. As you may expect, having the list of advantages, we will end up with a list of disadvantages. The first disadvantage of this design is that it's more complex. When we speak about complexity, it's not an algorithmic complexity, but it's a complexity related to the use of several abstract layers. In this case, the code will be quite complex and also it will be time consuming since, as you may expect, hard coding the solution will be optimal than adding extra layers, extra abstract layers. Also, we may require to add some documentation when the user need to use the strategy A and when the user required to use the strategy B. In those cases, also we may require to have some user experience or expertise that will allow him to determine the appropriate strategy. The last point is related to defining the appropriate interface. As you may expect, defining an interface that will allow us to support several strategies and those strategies that we will add in the future will be quite challenging. With this brief introduction, we have finished the first part of presenting the strategy design pattern, and we will jump to present the delegate design pattern. In this part of the presentation, I will introduce the delegate design pattern. But before this, I need to mention one point, that many authors may not describe the delegate design pattern as a design pattern by itself. But in the design pattern language, we consider that the delegate design pattern is an important design by itself, and we extract it as a design by itself. At this point, the question is, what is the delegate design pattern? As many authors may mention that the delegate design pattern will offer support for multiple inheritance in languages where we did not have support for multiple inheritance, like for example, Java. In this case, we will end up having a parent class and a child class. In general, we will end up with a specific relationship, which is a, that will allow us to inherit all the properties, method, and functionality from the parent class. Just I need to mention that this depends also from the paradigm that we will use, also from the language that we will use, also the language capability, since, for example, we need to check the visibility to determine the properties or the method that we will inherit. Let's imagine that we will add a second parent. In this case, we will not be able to add a second is a. In those kind of cases, we will end up with another specific relationship, which is has a. We will read this that the child will have some properties from the parent too. In another term, he will have properties, method, or some functionality. As we have mentioned, this will depend on the paradigm. With this manner, we will be able to offer support for multiple inheritance in paradigms or languages that did not offer support for multiple inheritance. As you may remark, also we call this as object composition, since we will compose an object with a set of features to create the most appropriate object that will answer a specific business logic requirement. In those kind of cases, we will avoid strict inheritance, since we will not rely on inheritance to inherit all the method or functionality from the parent class. And we will, let's say, select or pick the most appropriate functionality to compose the object. I need just to remember that you need to check the paradigm, also the language capability, like the visibility, for example. Also, there are another mechanism that we call mix and match. By mixing, we mean that we will compose the object of a set of functionality to match a specific business logic requirement. In another term, the object that we will create will answer a specific business logic requirement. Also, the delegate, we may opt to a simple delegate that will delegate the responsibility to one object, or those complex delegate in which we will opt to use a set of objects that we will delegate to them a certain responsibility. In the design pattern language, we have a variation of the delegate design pattern. The first variation is the remove delegate. With the remote delegate, we will opt to use an object in a remote environment. We will delegate the responsibility to use that object to a specific object that present the remote delegate in the local environment that will handle the connection, the lookup, the request, and all that process, even the exceptions, if there are some exceptions that may happen. Also, we have the virtual delegate. The virtual delegate, we will create or we will delegate the responsibility for a local object to present an expensive object. With this manner, we will be able to process those expensive operations in the virtual object that will allow us to have a layer of optimization to be more optimal. Also, in the design pattern language, we have the proxy delegate. But in the design pattern language, we opt to have a specific proxy delegate. In another term, the proxy is quite specific to the access permission. In another term, we will add the proxy just to check the access permission. Just a remark, please be careful when you use those definitions, since those definitions are specific to the design pattern language. I will give an example. For example, for the remote delegate, this is the definition of probably the proxy in other documentation. For this reason, if you use those definitions, please refer to the design pattern language. Since this design is not a common design, I would like to consolidate those definitions by bringing two examples. The first example will be person and student, and the second example will be the coffee shop example. First, let's start with the person and student. Imagine that you will ask for my help to help you to design a system where we have two classes, a person and a student. And you will ask me the following question: what is the relationship that should exist between a person and a student? In this case, probably the first question that I will have in my mind is the student a person? All of us, we know this question. Yes, it is. As you may remark, this is a quite naive question, since this question will not help us or will not bring some business logic value to the system that we are designing. The most important question in this case is, did the student require all the properties or all the functionalities of the person? Here we need to determine this question, the answer of this question, by checking the business logic requirement. Also, we may add another question. If we add a new properties or new functionalities to a person, did the student require to have those functionalities? The answer here will rely on the business logic requirement, not in our opinion. In those cases, if we will answer yes, probably we need to opt to inheritance. But if we will answer by no, probably we will opt to use composition or to delegate the responsibility by composing the object based on a set of functionality. With this, we finish the first example. Now I will jump to the second example, which is the coffee shop example. Imagine that a manager will come and ask me to design the system. And as you may expect, it's a long story, yada, 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 yada. And I will finish by designing the class coffee. Okay, in the class coffee, as you may expect, I will add all the topics or the flavors that we will use on the coffee. For example, a black coffee, milk, sugar, a cream, chocolate powder, all those, let's say, topics we will add that. And we will add the functionality that he will require, and we will ship the code. And everything will work fine. Until one day I will get a call from him, and he will say that for some reason the application did not support some business logic requirement. And I would go to check what are those business logic requirements, and I would discover that there are some guys that they would like to enjoy their coffee, and for some reason they will ask for those specific order. For example, they will ask for coffee with double milk, triple chocolate powder, double sugar, double cream, which is a quite specific order. In those cases, that we will be able, let's say, to give a particular answer for this business logic requirement, we need to extract those topics or those flavors. And in this case, the cashier will mix those functionalities or those properties to match a specific business logic requirement that they will get from the client. I hope that you get the idea of the difference between the strict inheritance and the composition. I would use this example in the design pattern language layer in the following slides. But for the moment, I hope that you get this example. As we have seen with the strategy design pattern, the most important slide is the slide in which we will see the forces of the delegate design pattern. Okay, as you may remark, we have two lists. The first one is the list of advantages, and the second one is the list of disadvantages. At this point, let's start with the list of advantages. As you may expect, using the delegate design pattern, we will be able to avoid all the strict inheritance constraint, and we will be able to compose those objects on the runtime. As we have mentioned, this composition will allow us to give an answer for a specific business logic requirement, since we will be able to mix and match several criteria. All this will happen on the runtime, since we will be able, let's say, to compose object on the runtime to give a specific answer for a specific business logic requirement. As a result, we will be able to add several layers of optimization. We will be able to have lazy instantiation. We may delay the execution. We may cache some result, etc. Also, this will allow us to have the possibility to reuse several objects, which is quite beneficial in some particular cases. Moreover, we will be able to be transparent to the client. I will give the coffee shop example. In this example, as we have seen, we may create a simple coffee, just a black coffee, we ship it back to the client, and the client will be able to execute it. But in other cases, we will be able to compose the coffee with several topics or flavors, and we are able to ship it back to the client. For example, we may create a black coffee, we will add milk, we will add double sugar, we will add cream, we will add chocolate powder, and we will send that object to the client. As you may expect, we will mix too much a specific business logic requirement, and the client will be able to process that. As we have seen also with the strategy, since we have a list of advantage, we will end up with a list of disadvantage. The first disadvantage of the delegate design pattern is the complex configuration. As you may expect, mixing those flavors or topics may cause some issues, and at some point it will become a complex task to mix those topics or flavors. Also, debugging the system, since all this configuration will be on the runtime, became a quite complex task. Also, as you may expect, if the system is not well designed, we will end up with what I call a debugging hell, since we will have several recursive calls, and we will pass an important time, let's say, to figure out what is the issue exactly. Also, maintaining the code and the learning curve will be quite important. As we have seen with the strategy, also with the delegate, adding an extra layer will make the system more complex, since adding each extra layer of abstraction will cause the system to be more complex, more hard to use. As we have seen, since we would use those objects on the runtime, or we will compose them on the runtime, we may end up with those runtime exceptions or runtime issues, and we need to handle those issues or exceptions in the most appropriate way. The last point is related to the delay related to the network. As you may expect, using, for example, the remote delegate, we may use the wire or the network, and this may delay the execution. Just it is a simple remark that you need to take care of. In this part of the presentation, I will present the first layer of the design pattern language, which is the meta design pattern. As you may expect, I introduce those two designs, the strategy and the delegate design pattern, since I will use them to describe this layer. In this layer, as you see in the screen, we have the delegate design pattern and the strategy design pattern. Just as a remark, this is not a UML diagram or class diagram or any other diagram. This is an organigram in which we will try to present design pattern in the most appropriate way to use them and to present how they share forces. Okay, let's take a look on the delegate design pattern. The delegate design pattern contain the set of forces of the strategy design pattern. As you may expect, we have a specific relationship, which is containment, that mention that the delegate design pattern will contain or will include or will have or will englobe the set of forces of the strategy design pattern. Okay, probably it will be better if I can give you a better example. As you may see in this slide, I put side by side the set of forces of the strategy design pattern and the delegate design pattern. I will try to read the advantages of the strategy design pattern in the delegate mode. In this case, what I will say, using the delegate design pattern, I will be able to delay the decision, since delaying the decision is the most appropriate decision in some cases. Also, using the delegate design pattern will allow me to make those decisions on the runtime. Moreover, I will be able to support those non-clear scope using the delegate design pattern, since I will rely on a delegate layer or delegate node. I will be able also to support several delegate. Moreover, I will be able to add a new delegate in the runtime or in the future. I will be able, in addition, I will be able to plan to extend my solution in the future. Also, applying modification will be quite simple, since I will tackle the delegate layer or the delegate node where I have an issue, and I will try to update the code there without touching or impacting other layers or other nodes. which is quite important to maintain the system. In this part of the presentation, I will introduce the design pattern layers. As you may expect, the meta design pattern layer is the first and the most abstract layer. We have 4 other layers. The second will be the feature design pattern layer, the core, or the new name is the domain design pattern layer, the application and the deployment design pattern layer. In the following slides, we will see each layer with more detail, and I will describe each set of family of design pattern to give you an overview of how to use this design pattern language layers. But first, let's zoom in to see more detail. Just the first thing I would like to highlight an important point. If you remember well the example of the coffee shop in which we extract the topics or the flavors and we use a basic concept and a set of features. In general, we will call that not a delegate design pattern, but it will be called a decorator design pattern. As you may expect, the decorator design pattern will contain all the forces of the delegate design pattern that will contain by itself all the forces of the strategy design pattern. Even that the definition it's not the same, but we will contain the set of forces. Just this point, you will find this point and other points with more detail in the book Design Pattern Language, the Timeless Approach for Software Design. Also, just to present the point that more detail about each design and those layers will be found in the book. But first, let's jump directly to present the feature design pattern layer. In the feature design pattern layer, we have visitor, we have proxy, virtual remote, we have null, and template method. All those patterns will add a specific value to the design that you will opt to use. For this presentation, I opt to present the null design pattern and the template method design pattern. I will give a brief definition and some characteristic of those two designs. At this point, I will start by presenting the concept of null design pattern. But first, when we will need this null design pattern? Imagine that I will invoke a remote object and I send a request and I get null. How can I determine that that null present the non-existing of the appropriate object? Or how can I determine that I didn't end up with having an exception that generate or throw a null? Especially since in some languages, we may end up by returning null. Return null, it's valid instruction, for example, in Java. In those cases, I will require to have a specific type that will mention for me that I navigate the entire chain or I make the appropriate call and I navigate the entire system. I didn't find any object that is confirmed, for example, to my request, and I will return a specific object that mention we have navigated the entire system without finding the appropriate object. This object will be a specific implementation of the interface that we will opt to support. In this case, it will be a specific type that present the null concept. In another term, it will present the border, the limit, the tag, a flag, something mentioning the appropriate end of the navigation. I will give the example of JavaScript. In JavaScript, we have null and undefined. But imagine JavaScript with just null, without undefined, or with undefined and without null. Null, as you expect, it will be quite complex. Also, we will end up with those kind of problems that we are unable to determine what is the issue that we are running with. For this reason, having those two definition of null concept will bring an additional value to the developer that he will be able to determine what is the issue and if there are an issue in the system that he require to fix. Just the last remark, I would like to mention that probably the null as a name is not quite appropriate. I highly recommend that you opt to add a name or to make a name that reflect the business logic requirement of the appropriate end of the chain or of the navigation. This will depend on your team. Probably you may opt for something that is more structural or something that is more oriented to the business logic. The second design that I opt to present is the template method design pattern. Okay, I expect that all of us have an idea about the template method design pattern. It's quite simple. We used it before. In general, we will end up with the supertype, and the subtype. There are specific relationship between both of them, which is in general kind of inheritance is depend on the paradigm, the language capability. But the concept is quite simple since we will look to redefine some functionality or some method or some concept in the new subtype. In general, the subtype will give a specific answer for the business logic requirement. In another term, when we have a specific business logic requirement, we will opt to create a subtype that will give an answer for that requirement. For the template method design pattern, we opt to add several characteristics for this design. One of those characteristics is what is the method or what is the functionality that I need to redefine. In my opinion, this needs to be quite clear for the developer. For this reason, I will highly recommend that I see an abstract class in which I will see an abstract method that it is clear for me that I will be required to offer a specific implementation for that method or functionality. Even that in some cases, we may offer a default implementation. I highly recommend that the default implementation will be extracted in a specific subtype. This will allow the developer to determine that he needs to offer that specific functionality. Also, as you may expect, having an abstract method will mean that probably we will require to have some final method. In another term, in some cases, we will not offer the developer the possibility to override or to re-implement all the methods. For example, if I have an access permission, I should limit the capability of the developer to not override the access permission. In those cases, opting for a final method is one of the best solutions. Also, another characteristic is using the concept of a hook. In this case, the superclass will use the functionality in the subtype. In another term, I will not allow the subtype to use the functionality of the supertype. This is quite important, especially if I would like to limit the functionality that exists in the subtype. Also, this should be done by design when I design the supertype. As you may expect, in some cases, the developer may find himself with several constraints that we have added, and he is enabled, let's say, to redefine those functionality or those methods. In this case, the developer may opt to, he will try to create a second supertype that will allow him to redefine a set of method or functionality. In those cases, we need to limit the possibility that the developer will pass by the template method that we have created. In another term, the code need to rely on the supertype that we have created, since he may, for some reason or another, he may create a second supertype just to pass by the constraint that we have added. I should mention an important point that probably adding all those limits to the design by design will create a problematic for the developer, and also probably will cause the system to be, or will cause that template method to be obsolete at some point. For this reason, I highly recommend that you use the most optimal characteristic for this design. Next, I will introduce the application design pattern layer. In the application design pattern layer, we have two families. The first one is the creational family design pattern, and the second one is the connector or the integration design pattern family. Okay, I will start by presenting the creational design pattern family. As the name suggests, those family of design will allow us to create the appropriate object. As you may expect, relying on design pattern may cause the creation of the appropriate object to be a complex task in some cases. Let's take the example of the coffee shop. In the coffee shop, if you remember, of course, that we was being able to extract those topics and those flavors on a set of classes. The creation of a sample coffee in this case would be quite complicated in some cases, but sometimes the creation is quite straightforward. In another term, if we will create an espresso or cappuccino, the configuration should be quite simple, and as the user expect, we will not add any extra special treatment. For this reason, we may use the factory method to create those sample object that we may create a simple configuration to create them. In general, in this case, we will support all the items in the menu that the cashier will be able to create them by default. But as we have presented, life is not quite simple. We may end up with those specific order. In this case, we will opt to use the builder design pattern. The builder will allow us to build those specific objects that give an answer for a specific business logic requirement. In some cases, things will be even more complicated, since imagine that yes, we will serve coffee, but also we will serve tea, and also for the tea there are some specific topics and flavors. In this case, we will opt to regroup the flavors and topics of coffee in a simple factory method, and for the flavors of the tea in another factory method. In this case, we will use the abstract factory design pattern. The last design on this group is the prototype design pattern. This design will require to have at least one instance that we will be able to duplicate. In another term, if we take the specific order from the client, we can duplicate it, or if we have a list of the history of order of that client, we may duplicate the order again. Now I will jump to present the connector or the integration family design pattern. In this family, we have the simple design pattern, which is the connector. With the connector, we will be able to connect or to invoke the appropriate object. As you may expect, this is a simple design pattern since we will not add any new business logic requirement. It will be just a simple call. But in some cases, we will opt to extract this object. We will opt to extract this object in a particular object to be able to add some extra treatment or to be able to, let's say, pick the appropriate connector on the runtime. But the most used design pattern in this family is the adapter design pattern, since in some cases we may end up with two interfaces or where we would like to connect to an existing system. In this case, we will adapt the new call to the existing system through the adapter design pattern. Okay, another design, which is the bridge design pattern. This is a quite specific design, since we will manage this. We will use this design when we manage the two subsystems. In another term, we will have from one side the implementation, and on the other side the use of that implementation. In this case, we will be able to apply change on both of them independently. This is one of the most interesting design that you need to take a look on it. The last layer in the design pattern language is the deployment design pattern layer. In this layer, we have a set of design patterns that will simplify the deployment phase of our application. The first design is the singleton design pattern. With this singleton, we will create a global instance or a single instance that will process all the requests in the system. We may opt to use the multi-ton design pattern that will allow us to create an instance per ID or per request. Just a remark, as you may remark here, we share the forces, not the definition of design pattern, of each design pattern. Also, we may use the flyway design pattern. The flyway design pattern, we will use this design pattern when we need to enhance the space complexity. After we realize our application, probably we will profile it, and in the profiling phase, we will look to determine those mega objects. And when we determine them, probably we will be able to extract some properties to share them between several objects. We will rely on the flyway design pattern to achieve this goal. Or if we will create an important number of objects, probably we will need to make some optimization by avoiding the creation phase. In this case, opting for a pool of objects will allow us to reuse each created object. Since in this case, we will be able to create object in the pool, ask for an object, get it from the pool, use it to process request, and send it back to the pool, and he will be available to serve for the next request. The most important layer in the design pattern language is the core, or the new name domain design pattern layer. In this layer, we will find 5 families that each family is an oriented business logic requirement that will allow you to pick the most appropriate design based on the business logic that you deal with. Let's start with the simplest one. I will start with the state design pattern family. In the state design pattern family, I have the state design pattern. As you may expect, it's quite simple. Imagine that I have a lamp. The lamp have 2 states, on, off. From on, we go to off. From off, we go to on. etc. Probably you will draw the state diagram that will allow you to design your system in the most appropriate way, and you will implement it as usual. But life is not quite simple, since in some cases we may require to see the state of more than one element. For example, we have the state of the lamp, the state of the button, and the state of the interrupter or the fuzzy box. We will require to have the state of those three elements. In this case, we will opt to use the snapshot design pattern. As you may expect, the snapshot design pattern is the crossover between the state design pattern and the composite design pattern. This design will allow us to, as I have mentioned, to determine the state of each element at a specific point of time. Also, the business logic in some cases is quite tricky, since in some cases we may require to rule back the states. In this particular case, we need to opt to a memento state design pattern or memento snapshot design pattern. With this design, we will be able to rule back the state of the system, since we will be able to register them one by one. In those kind of cases, we need to determine the appropriate event, the appropriate state that we will save. All this need to be determined before the implementation. Similar to the state family design pattern, we have the command family design pattern. In the command family design pattern, we have the command. And here we will deal with commands. In general, something similar to do, undo, redo, etc. And you need to model them in the most appropriate way. But as you may expect, in general, we will end up with those micro commands where we will compose command on a set of commands. As you may expect here also, the micro command is a crossover between the command design pattern and the composite design pattern. This will allow us to have those macro commands that will fulfill a specific business logic requirement. Also, in the command family design pattern, we have the memento command design pattern that will allow us to undo the list of commands that we have executed them in a previous, let's say, point of time. Similar to the state and the command family design pattern, we have the receiver family design pattern. In this family, we have the simplest design, which is chain of responsibility. The chain of responsibility is a quite simple design. In this case, we will have an object that will receive a request. When he receives it, he will try to determine or evaluate if he is able to give an answer to that request. If yes, he will process it and send back the result. Otherwise, if he is unable to handle it, he will send it to the next responsible object. In this case, we will keep sending the object until the last object in our chain. At that point, we need to determine the appropriate, let's say, scenario that we may opt for. In some cases, we need to opt to have a default scenario. In other cases, we may opt to use or to throw an exception. In some cases, if the business logic allow us, we may ignore even the request. All this need to be treated or need to be determined before starting the implementation. The second design in this family is the interpreter. As you may expect at this point, the interpreter is the crossover between chain of responsibility and also the composite design pattern. Next, I will jump to present the notification family design pattern, which is a quite specific family of design patterns since we will manage the notification or sending messages. The first design is the most simple one, which is the observer design pattern. With the observer design pattern, we will have an observable and observer object. The observable will hold the reference to all the observer, and he will send a message to them whenever he have a new message to send. But in general, we may end up with more complex scenarios. In those scenarios, we will end up with a publisher and subscriber. In this design of publisher-subscriber design pattern, we will opt to use an event handler. The event handler will be the object responsible of receiving the message from the publisher and forward the message to the subscriber. In general, here also he will manage the subscription, he will manage the notification, push, pull, etc. Similar to the publisher-subscriber design pattern, we have the mediator design pattern. With the mediator design pattern, all the nodes are publisher and all the nodes are subscriber. We will end up with the concept of colleague, since all of them may publish and may subscribe. The last design and the most important design in this layer is the structural family design pattern, in which you will find the decorator, the composite, and the facade design pattern. As you may expect, this is a brief introduction in which I present all the designs that we will see in the design pattern language. It was been just an overview about all those designs that we will use. For more details, like for example, the definition, the forces, the relationship that exists between all those different designs, I highly recommend that you opt to check this in the book, The Design Pattern Language, the Timeless Approach for Software Design. But for the moment, I would like to, let's say, jump to the design pattern layer. And as we have discussed, each layer have group and families, and each families have a set of designs. As we have presented the difference, I will say briefly, we present the difference between each designs. But until this point, I didn't present the pattern sentence. For this reason, I will opt to present this concept in this slide. For this reason, I will take the example of the coffee shop and I will present it in 3 sample scenarios. The first scenario, imagine that the manager of the coffee shop come to me and ask me to design a system. And in that system, he planned to use just a pot for tea and a pot for coffee. No configuration, no variation, no menu, nothing. Just a simple coffee shop, the most simple one. In this case, probably the most appropriate way to design that system is to just hard code it. I don't see that I need to use any design pattern. The second scenario will be, imagine that the coffee shop manager will have, for example, a pot of tea, a pot of coffee, a pot of milk, some beverages, orange juice, whatever beverages he will opt for. And the user may come and he asks for whatever beverage he would like to have. In this case, probably the question will be, did he will opt to mix and match in the future, or did he opt to add a new, let's say, pot in the future, etc. Those kind of questions will allow me to determine if he will opt to extend the solution. If he will not opt to extend the solution, probably he will opt just to add several, let's say, type of pot in the future. The most appropriate design in this case is to use the strategy design pattern. I will use this strategy. I will be able to support all those new strategies that he will add in the future, and the system will remain quite simple. The third scenario will be if the manager of the coffee shop, yeah, he may mix and match. He will took those quite specific order to fulfill the requirement of his client. In this case, probably the most appropriate design that I will opt for is the decorator, as we have discussed. As you may remark, in this kind of cases, we will end up by starting from the entry point, which is strategy, to check if really we need to opt to use any design pattern. In some cases, we will not opt to use any design pattern, which is fine, that exists in the nature. But in some other cases, they are not particular, but in some other cases, we will opt to use just a strategy will be quite enough. If strategy will not be enough, we will opt to use whatever design that will allow us to fulfill the specific business logic requirement. In general, if we will opt to use decorator design pattern, we will opt to use a factory method. We will opt also to use the builder. Also, we may use whatever design that will allow us to make the solution more optimal or to connect to existing system. All this will be based on the business logic requirement that the client will ask for. Just to recap, as I have discussed, we have seen the family, we have seen the group. Also, we have seen the pattern sentence, we have seen the containment refinement. The last point is what is the difference between the design pattern, more specifically the GOF design pattern, vice the pattern language, more specifically the design pattern language. As you may expect, with the design pattern, we will opt to fix a particular issue. In general, also this issue related to the code that we will try to fix it. In general, this approach will be a bottom-up approach. Compared to the design pattern language, we will opt to fix a specific business logic requirement. We are looking to build a solution based on an existing problem in the business logic that we will deal with or we will handle. In this case, it is a top-down approach. Okay, another important point is the type of implementation. When we speak about the design pattern, each design we may implement it in three ways. The first one, which is the simplest one, which hard-coded. We will hard-code the design. It's quite simple, it's quite efficient, is widely used. We will not have any particular issue with it. Just when we would like to extend it, probably it will be quite challenging to extend it. The second manner is a hard code configuration. I will give the example of the state design pattern. In this state design pattern, we have state A and state B. We may hard code the configuration. From the state A, we will just jump to the state B, and from the state B, we will just jump to the state A. As you may expect, this is quite useful, even if we will hard code the configuration. But in some particular cases, it will not be quite useful as you may expect. In those cases, probably we need to opt for a dynamic configuration. On the runtime, we will create the state A and the state B, and we will add the configuration that the state A will jump to the state B, and from the state B, we will jump to the state A. In this kind of implementation, we will be able even to create the state C on the runtime, and we will be able to jump from A to C and from C to B. All this, we will manage it on the runtime. As you may expect, each of those implementations have its own limit. But in general, you need to be careful because the type of the implementation that you will opt for probably will impact the pattern. In another term, the same design pattern, it is a useful pattern, but if you will opt to the wrong implementation, you will end up by making that pattern as an anti-pattern. In this slide, I would like to speak about the anti-pattern, more specifically, how we can avoid the anti-pattern. As I show you, in the design pattern language, we have an entry point and we can navigate the entire designs to pick the most appropriate design pattern. I will take the example of decorator. Let's take the example of the coffee shop. With the coffee shop, imagine that we have processed all the requests and we determine that we need to use the decorator. But for some reason, we say, let's even opt for a more complex solution, which will rely on the composite design pattern. In this case, we may opt for the composite design pattern. But as you may expect, the composite design pattern in this case will not reflect the real business logic that we deal with. In this case, it will be even complex to code it in the first place. The code of the solution, which means to make the code of that solution, will be quite complex since it will not reflect the business logic that we deal with. Also, it will be quite hard to use it since we will use just a particular case of that design. But the main problem will be when we would like to maintain it, since we will maintain just a particular case, which is in the composite design pattern. As you may expect, this will make the design from a design pattern, he will switch it to an anti-design pattern. For this reason, we highly recommend that you stop in the first design that fulfill the business logic requirement. The most important point here is that we have an entry point. We can check if the design is useful or not. In the case that we reach a design that will offer us a solution, we should stop there. Don't go further. You will raise the complexity, and at some point, that pattern will become an anti-pattern. Also, I need to mention an important point. Even if you opt to use decorator, and it is the appropriate pattern, but if you implement it in the wrong manner, or you will opt to use the type or the non-appropriate type of implementation, in that case, you will end up with an anti-pattern. Okay, now I will jump to present the last point of this presentation, which is the complexity. I believe that no one cares about the complexity in design pattern. It is just me, since I believe that this is a language. But just bear with me on this last slide. Okay, I agree that we will not require to check the complexity if we will add each layer manually. Checking the complexity would be quite important if we will use the design pattern in operating system or in ERP or CRM or framework. At that point, yes, it is quite important to check the complexity that you will add to the system using that design. But in general, what I have remarked at least that we will end up with a sample complexity if we will rely on the design pattern. Okay, you will find all the detail in the book, but just I need to mention that we opt to pick the worst complexity. Also, I would like just to give you an example. Imagine that we have the observer design pattern, and we will just add a new observer on the list or in the linked list or chained list, and we will navigate all those observer until the last observer that we will be able to add or to insert a new observer. In this case, as you may expect, the complexity is O of n. But if I would like to, let's say, to reduce it, I may add in my data structure the tail property, and this will allow me to have a constant complexity. As you may expect, and as you may see, that we will speak about the complexity even before starting, let's say, writing the code. In design, we will start think about the complexity and how we can reduce that complexity. Just the last remark is that uh, be careful to, since the same rules that we apply in complexity still valid with the design pattern complexity. That if we access to the disk or we will go through the network, this will invalidate the complexity. Okay, congratulations. We reached the last slide of this presentation. But as I have mentioned, that this presentation is an offline presentation, and for this reason, I opt for to present a question that, or a common question that I keep getting whenever I present the design pattern language. I consider that this question is a pattern question. This question is, it seems quite important to convince guys to adopt or to at least follow us on this language. The question is the following. I use design pattern since I love design pattern or even I hate design patterns. But whenever I use any design, I do not see those advantages and disadvantages. In another term, whenever I use design pattern, I do not see those forces. Can you please show me those forces in a particular design? In general, we will end up speaking about the singleton design pattern for some reason. And I would like to take this example to explain it more in detail to give you a better overview about how those forces are presented in the singleton design pattern. For this reason, I will present the singleton design pattern. The singleton is a quite simple design since we need just one instance that will process all the requests coming from the client. In another term, we will have one object. That single object will give an answer to all the requests coming from the client. For the singleton design pattern, we opt for the following presentation. As you see, we will have a client class and the singleton class. The client is responsible of generating the requests, and the singleton is the object that will handle all those requests. Okay, we will have a private instance, we will have private constructor, and we will have get instance. The simple scenario will be that the client will invoke get instance. If it is the first time, we will not have instance property. For this reason, we need to create that instance through the private constructor. We will assign that new object to the instance, and we will send a reference of that object to the client. For the next request, we will check directly on the get instance, and we will have an instance. We will send a copy of the reference to the client. It's a quite simple design, and this will allow us to have just one and only one object that will process all the requests. But at this point, the question is, how can I see those forces? I'm unable to see those forces. For this reason, I plan to show you the slide of containment. But just I need to remember you that the strategy design pattern will contain the forces of the delegate that contain by themselves the forces of the strategy design pattern. Okay, I will opt just to read the first 3 or 4 advantages of the strategy. Theoretically, I will read them on a singleton manner. What I will say, using the singleton design pattern, I will be able to delay the decision. In reality, I don't see that I will be able to delay the decision. It's not delaying any decision here. Probably a lazy instantiation, but not delaying the decision. Using the singleton design pattern, I will be able to make the decision on the runtime. Yes, we create the object on the runtime, but we did not make any decision on the runtime. The singleton in this case is able to support the non-clear scope. In my expectation, no. Are we able to support several singleton strategies? In my opinion, no. Okay, in this case, I need to jump back to the class diagram. As you may expect, all the answers are probably no. For this reason, I have the following question. Where are the forces that we have presented? Okay, let's be more focused on 2 points. The first one is the type of implementation, and the second is the anti-pattern. Those 2 points, I present them briefly on 2 slides. You can jump back to check them. But for the moment, just bear with me. I would like to explain what is the issue of this presentation. First, we speak about the type of implementation. We have said that we have 3 types of implementation: the hard-coded implementation, the semi-dynamic, and the full dynamic configuration. At this point, I will ask you to pause the video and check what is the type of the implementation that we opt for. I expect that you will tell me this is a hard-code design pattern. We hard-code the singleton design pattern. And since we hard-code this design, we change or we flip the set of forces. In another term, as we have said before, the type of implementation that you will opt for will impact heavily the advantages and the disadvantages. In another term, it will impact heavily the set of forces. And this is the reason why you may the same design is the appropriate design if you opt for the appropriate implementation, and also an anti-pattern if you opt to the wrong implementation. This is the point that you need to be aware. In the case of this presentation for the singleton design pattern, I would say that you have hard-coded the singleton design pattern. In this case, you have flipped the set of forces. In another term, the advantage became disadvantage, and the disadvantage became advantage. Just bear with me. I will read for you the advantage of the hard-coded singleton design pattern. What I will say the hard-coded singleton design pattern is not complex. As you may expect, it's quite simple. It's not time-consuming. Since I will hard-code it, it's quite simple. We don't require any documentation because the code is quite clear. Reading the code, it will be far away efficient than adding whatever documentation. We will not require any experience from the user. It's quite straightforward. We do not require any interface. There are no complex configuration. No one need to debug that presentation of singleton design pattern since it is quite simple. Also, we will never have any runtime issue unless your issues are related to the language that you use. Otherwise, I don't see how you may end up with whatever issue with this hard-coded singleton design pattern. Okay, I hope that this answer convinces you that the choose of the type of implementation is quite fundamental on terms of managing forces. Probably now the question is, okay, you show me that I was been using the singleton design pattern in a hard-code manner. Can you now show me the most appropriate, in my opinion, the most appropriate singleton design pattern? First, the most appropriate design pattern will rely heavily on the business logic requirement, not in my opinion. In another term, in some cases, that presentation is the best presentation that you need to opt for. You hard-code it as we have presented, you hard-code it, it's far away enough, and it's the best solution. But if you require to have a singleton that will allow you to pick the most appropriate instance on the runtime, at that point, you need to opt for the following presentation. Before presenting this, I would like to give a sample scenario. Imagine that I have a browser and I have some component, some for dark theme and some for light theme. Okay, in general, I need just one and only one instance from that component that will process all my requests. In that case, I will opt for the following presentation. The client will send the request to the singleton. In the singleton, we have get instance. We will check if we have an instance. If we don't have an instance, we will opt to invoke the most appropriate factory method. The factory method may depend, for example, on the time in the browser, some preferences, or some information related to the session that the user opened. Depend on those information, we will opt to create the most appropriate concrete product. In this case, for example, light or dark theme, whatever whatever the most appropriate concrete product. We will send that concrete product through the factory to the singleton. And whenever we will have the next request from the client, we will directly ship back the reference of the object that we have created. As you may expect, those two presentations are for the same design, but they are quite different. And this difference causes that the same design is an appropriate pattern, in some cases, and will cause him to be an anti-pattern or anti-design in other cases, which we highly recommend to be aware of those points. I hope that this question will allow you to have a better understanding about why you did not see those forces before when you use descent pattern. I hope also that this will show you the light by the end of the tunnel, that there are something that you didn't use before, and probably it's time to go to discover it. I highly recommend that you, let's say, recheck this. Otherwise, I highly recommend that you opt for your copy from the book, Design Pattern Language, The Timeless Approach for Software Design. Woohoo! We reached the final and the last slide. I'm so excited as always when I reach the final, let's say, slide in the long format presentation. First of all, thank you very much that you bear all this time with me. I expect it's almost 1 hour or more. Okay, in this presentation, I present the design pattern language. Also, I emphasize that I would like to mention that all the detail about this language are available in this book that is available in the market now. Okay, probably at this point, I would like, let's say, to recap. First, what is the design pattern language? In the market or in the state of the art, personally, I didn't find any pattern language that convinced me to use it. Always there are some proposals, but they are not well formulated. For this reason, I opt to formulate this design pattern language. I hope that this pattern language will allow you to solve some problem, especially in communication. I expect also that if you look for a better manner to regroup or to use design pattern, that this language will offer some kind of solution for your problem. I will be happy if you, of course, if you agree and you adapt this language. And for sure, I will be also so happy if you can subscribe in our social media accounts, that we will keep in touch, whatever new resource or new information that we may share in the future. Speaking about the book now is the only available resource that will allow you to understand better the design pattern language. In this book, you will find a detailed description about each design by itself. In the book, you may find some redefinition of some designs, but in general, I opt to present the old definitions that exist in the state of the art. Okay, also this book will allow you to see the new classification that we opt to use that will allow you to simplify the task of using design pattern. Also, this book will allow you to have a better distinguish between each design and other designs that are quite similar. In my opinion, this book also will offer solution for guys that will opt to use frameworks that rely heavily on design pattern. For examples, I highly recommend that you take a look on Form.js, Form, which is feature-oriented active model, JS, which is a JavaScript framework that rely heavily on design pattern. It's one of the best framework that rely on design pattern. Okay, we reached the end of this presentation. Thank you very much for your time. Thanks for this opportunity to discuss and to present my book and my language, and see you in the next video.